I wanted to show you some things that we've been doing in class as far as talking about subtraction strategies. I've got the problem 52 subtract 28, and we first started doing this by place value blocks in class. 52 is the same thing as 5 tens and 2 ones, and I need to remove 2 tens and 8 ones. I've got enough tens that I can remove 2, but my problem is I don't have enough ones to be able to remove 8. So one of the things that we've talked about in class is unbundling a 10, because this also represents 10 ones. So once I do that, I can replace the 10 with 10 ones, and I tell my boys and girls to put them in the shape of a tens frame so that they can see that that's still 10. So we still have 10, 20, 30, 40, 50, 51, 52. 4 tens and 12 ones is the same thing as 52, just written a different way. Now we're able to take away 8 ones, and we're able to take away 2 tens. When we do that, we can see that we've got 2 tens left and 4 ones. So my answer is 24. Well, what if you don't have the place value blocks at home? Well, you can draw it out. 52, 5 tens, 2 ones. That's 52. Okay, and that's real easy for the boys and girls to do. They know how many tens, they know how many ones, so they can draw that out. They need to remember that they can trade in or decompose one of these tens for 10 ones. So you heard me use the word decompose or unbundle. Decompose means break apart. We even talk about that in nature, so they can make the connection. Things that have died, they rot, they decompose, they are breaking apart. Here's 52. I still have 10, 20, 30, 40, 50, 51, 52, but it's represented with 4 tens and 12 ones. I have enough that I can mark out 8 ones. I can see that I have 4 ones left. I can mark out 2 tens. I have 2 left. Now this is representational. It gets a little harder when we are using other forms where they can't see it necessarily with the blocks. But one of my favorite and easiest ways to do this problem is with a number line. So I like to start small and go high. So I'm going to put 28 on this end. We've talked about how when you make a 10, tens are really easy to count on. So 8 and 2 make a 10. So 28 and 2 make a multiple of 10, which is 30. I'm trying to get to 52. So I already have 3 tens. I need to get to 5 tens. I can add 2 more tens, which is 20. I get to 50. I just need to go to 52. Adding 2 more, 52. So my answer is the leaps that I've jumped in between. 20 and 2 make 4. So again, that answer is 24. If this is a little bit complicated for your child to be able to do that many jumps at one time, you can do it a little bit broken apart even more. So 28, I can go 1 to 29, 1 to 30. So there's my 2 jumps from here. In 30, I can jump to 50 by going 10, and I get to 40, 10 to get to 50, jump 1 to get to 51, and another one to get to 52. So that's 10, 20, 21, 22, 23, 24. Still the same thing. Number lines, because this is subtraction, you can start at 52 here. You can start at 52 here, and you can count back. I can subtract 2 to get to 50. I can subtract 20 to get to 30, and I can subtract 2 more to get to 28. So it works the same way. I like to count up. It's a little bit harder sometimes for children to count backwards, even to count backwards in their head or to count backwards on their fingers. It's still a little more difficult. Okay, another thing that we have just been learning recently, it goes along with our picture. Remember, our problem is 52 subtract 28. When we added, we talked about how we can break apart those numbers. So I am going to put 52 and 28 in vertical form like this. But I'm going to break apart these numbers into expanded form. So 50 plus 2 and 20 plus 8. This is still a subtraction problem. These addition just goes with building the number. It doesn't have anything to do with that you're supposed to add these problems. Okay. And again, this is new for them. We started this week. Okay. All the numbers on the top, when you subtract, need to be larger than all the numbers on the bottom. And you can see there's a problem with the 2. It is not larger than the 8. So something that we can do is decompose or break apart a 10. So instead of 5 tens or 50, I'm going to have 40. That means the 10 will go here with the 2, and I now have 12. I tell the children that I just moved that 10 in front of this digit, so it looks like a 10 stick or a 10's rod. Now, all the numbers on the top are greater than the numbers on the bottom. So 12 subtract 8 is 4. And 40 subtract 20 is 20. And now I just add those numbers back together. And my answer is 24. Okay. Now, I know some of the parents are kind of like, why are you teaching it that way? Why don't you just teach it with an algorithm? Well, you show how to borrow and make that 5 a 4 and that 2 a 12. I get that. That's coming. That'll come more in 3rd grade. But when the children break it apart, they can see that 5 is worth 50. And that 2 is worth 20. Sometimes it really confuses them unless they have really good number sense, which they're learning that in 2nd grade. Then it's confusing for them later on. And they'll just start memorizing an algorithm and they'll have no idea why they are crossing out the 5 and making it a 4 and crossing out the 2 and making it a 12. Whereas here they can see that, okay, yes, I cannot take 8 from 2. So I do need to make that 50 a 40. I do need to borrow a 10. Just like up here, when I had decomposed this one, I could see that I had 4 left, but it represented 40. So that's why it's a little confusing for kids. But I hope this video was helpful, maybe to even assist you helping your child at home. But these are things that we're doing in class to help us understand subtraction. Thank you. I hope you have a great day.